In this question, you've been told that one of these areas will be infinite and the other one will be finite. One of them is looking for the area from 0 to 4. So if we were to hatch in this area, and the other one is going from 1 to infinity. So if we're going to hatch in that area, it would look like this. And just to look, they both seem like they should be infinite because they either go on forever up or they go on forever to the right. But we know that's not true because the problem has told us one of them is finite and one of them is infinite. And so all we can do without a calculator is go about solving these integrals. The first one would be the integral from 0 to 4 of 1 over x squared dx, or, written in a more helpful way, x to the negative 2. And the other one would be the integral from 1 to infinity of x to the negative 2 dx. But we know that we really can't evaluate an integral that has infinite limits or that approaches an asymptote. So we're going to modify both of these into improper integrals that would have a lower limit of b, and we're going to find the limit as b approaches 0. And in this case, our limit will be as b approaches infinity. And so we'll do each one separately. This first one, as we find the antiderivative of x to the negative 2, of course we'll add 1. So we'll have x to the negative 1 divided by negative 1, evaluated from b to 4. The limit as b approaches 0. So then that will be negative 1 over 4 minus a negative 1 over b, as this b is approaching 0. And that, of course, would have to be from the plus side because we're approaching 0 from the plus side, or the right side. So we can evaluate this first term. It will be negative 1/4. But we'll then be adding 1 over small which we know will go to infinity. So this is a divergent integral, and therefore this is our infinite area. So the next one we know must be the one that's finite, but why? We'd have to show it to the AP board. So let's erase some stuff and make some room. Everything's going to be the same as we had before. We will now have the limit as b approaches infinity of x to the negative 1 over negative 1 from 1 in this case to b. Evaluating this integral now, we will have negative 1 over b, and that's where b is going to approach infinity, minus a negative 1 over 1. And here when we evaluate this limit and we have negative 1 over something very large, this term will go to 0. Those two negatives will become a positive, and my answer will be 1. So this area equals 1. Seems crazy that something with so similar pictures have such different areas. Moral of the story, don't guess. Do the improper integrals. And know that if you ever approach a vertical asymptote or a horizontal asymptote, that's when an improper integral will be required.